displaying their stuff on a map, they often don't know where to start. And sometimes they're not looking to make this huge, custom, complex web application. Sometimes they just have a list of places and they need to make a map as quickly as possible to show the points. Or in other cases, they want something a little more involved where people can create custom tools for their audience to interact with and publish data to and so forth. In my years of working with maps, there's a really wide variety of tools and resources out there. So my main goal today is to share that breadth of resources with you and give you a bunch of relevant keywords and directions that you can take with you to follow up and make your own future map, whether you're going to pick up a programming language or whether you want to use an existing online service, or whether you have a map and you just want to learn how to design it better, and so forth. So I'm going to try not to get too into the technical weeds on any given tool or service. And this talk will probably be short and sweet. I welcome questions at the end. I won't yell at you if you blurt out a question, not at the end either. And yeah, sound good? Great, yep. Oh, and my name is Cristen Jones. My perspective is I am a software engineer. I am one of the co-organizers of a group called Maptime Boston, which my co-organizer Danny here is also with them. Danny, did you want to talk a little bit about what Maptime is?
We get together and make maps. Pretty much like once a month we try to do it, and we also have like lecture series. Our last event was at Facebook, and they talked about their tool to map on OpenStreetMap, this open source map, like the wiki of maps. It's pretty cool. If you're into maps, you should come. All levels are welcome. And we're celebrating Geo Week, Geo Awareness Week, so happy Geo Awareness Week to all.
Okay. Yes, because
We have more
tomorrow's
events
GIS
tomorrow.
Day.
Yeah, tomorrow's GIS Day.
I don't remember why that particular Wednesday is GIS Day.
ESRI started it.
ESRI started it, it's all their fault. I'll go into who ESRI is later. But okay, let's get into it. So you decided you wanted a map. One key thing I want to throw out there is that you probably want a map when the information is actually geographically relevant. A lot of people think they want a map when the location of their data doesn't particularly matter to the message they're trying to send, which is okay. There's a lot of other visualizations that you can do if you have a story to tell through your information that doesn't have to be geographical. So it's kind of not intuitive, but when people come to me saying I want to make a map, the first thing I like to do is ask, do you really need a map, or do you just need something simpler? Given that, assuming that you need a map, there's a few different ways that we can go about mapping information. So I will step through a few very basic map types. The tried and true choropleth map. This is where you are representing a quantity in different spaces, using a color ramp or something else. Or proportional symbols, where you have a shape that represents this particular place, and you alter the size of the shape based on a particular metric. A heat map is a similar idea, except we take the data that's at specific points and use some computation to compute the density of points at a certain place. I think computationally it gets pretty complex, but I think the end result tends to be easy to understand for people, where hotspots is the literal phrase for it, where a spot looks hotter, indicating that there's more going on. We'll get into different marks and different symbols soon, but I want to look at the process of making a map in a few different ways. So if you look at it in terms of, we have some inputs that are certain kinds of data, and then we have some outputs that's going to be a map of some sort. We can kind of split those into 3 different categories. So say that the easiest thing to start with is if you already have a data set. Somebody gave it to you, or you downloaded it from somewhere, or it's just sitting on your desktop for some reason. Harder levels, which we can get into, are data that you have to collect yourself, where you might go out and do a survey, or do your own analysis on a certain place and record the data. Or you can create your own data set altogether by running a completely novel experiment and surveying folks or whatnot. But if, in any case, the outputs can take a variety of different forms. So you can make a map that's just for viewing. So this could be a static picture. This could be just an image that ends up going in, say, a news article that no one's going to be tapping and interacting with. Which is a very different process from if you want to make an actual application where somebody's going to be typing something to search for something, or filtering a bunch of points to try to find the one relevant point that they care about, or so forth. But anyhow, I want to talk about the data that we have, or that we hope to have. So where are a few places that you could get data from? Danny mentioned OpenStreetMaps earlier. Literally called like the Wikipedia of maps. This is where we have metadata and attributes about the world, and to the extent that helpful users and volunteers have submitted information. So you can find streets, you can find buildings, you can find administrative boundaries. I haven't used OpenStreetMap as much as Danny has, but my understanding is that it is a wealth of information that is curated by a loving community of volunteers. There are also a variety of web portals that are helpful for the beginner looking for something to map. 2019 is a good year, because when I first started doing this stuff, in the early 2010s, there were not as many web portals as there are now, and not as many folks were putting their map information online. Now you can find a whole lot. So data.gov has data sets from all over the country in a nice searchable database. MassGIS has Massachusetts-specific information. There are a few other cities listed here that either have a wealth of information or are local and perhaps relevant to what you're looking for, and so forth. So let's say you have data. I went on a search to try to find the easiest ways to kind of just upload your data and have it show something. The one most people tend to know about is Google Maps. So I'm sure more people consume Google Maps than actually make a map from it, but it turns out that you can make a custom map. You can mark certain points, you can assign those points with custom icons and colors, and have whatever text you want pop up when you click it. It is a very user-friendly approach to, I need to make a map that shows some places for my friends to go to or whatnot. Google's not unique. Other map providers have these sort of features too. MapQuest has a similar functionality where you can add some places and save them to a list that other people can view. There's also a variety of tools online that have different pricing schemes, so they're not huge and popular like Google, but they're smaller and trying to be a real small business or something. So, so some advanced features might cost you, but the idea with Data Wrapper and the next few tools I'm going to show is basically the same idea where you can upload or otherwise specify what data you want to show, and the tool will guide you through the process of building your dream map with those. I haven't personally used these, so I can't vouch for them, but if you're in an exploratory mood, it could be fun. So Batch Geo, the screen has a really nice illustration of how it theoretically works, where you have a table of information and click Map Now, and it'll hopefully show you something pretty. ZMap's just another thing of that same vein. I want to highlight here that this tool and other similar tools take in a bunch of different formats. So in terms of data formats that you need to feed these systems for them to understand and map your information, you will want, you'll usually want like a table or a spreadsheet. So an Excel file works great, a text file of comma separated values. They'll all have their own instructions, but they will usually be expecting a column they will often expect a column representing latitude and a column representing longitude for each location. And if you don't have that, we will talk about geocoding, which will give you that. But anyhow, these are just a few different ways. This tool I wanted to highlight is called Geo JSON.io, and I enjoy it, but I'm a programmer, so I enjoy it because when you upload a file, it'll automatically populate this map on the side with it, and also translate that information into either a table or JavaScript object notation. So the JavaScript object notation, which currently is empty, so sorry, I hadn't mapped anything on the screen, but it'll be the same format that you'll feed a web application, like if you're building an app based on data. The table shows you the same information in tabular format, and it also makes it really easy if you need to edit the names or stuff like that. GeoJSON.io also lets you draw your own shapes. So if you needed to, there's a little toolbar on the side here where you can draw your own rectangles, slap your own points, and it'll take care of that for you. So those are some examples of things you do with data you have. I'm going to take the other angle for now and look at, okay, if we want to view this information on a map, how do we go about displaying that? So say we need a simple graphic. One important piece of terminology I want to highlight is called a base map. So you've probably seen these online, but this screenshot right here, on the left side you have an example of Google Maps, and on the right side you have an example of Apple Maps. It's the same location, but it looks different. And each of these companies have taken a different approach with exactly how they want to style their base map and what kind of points they want to highlight. Apple wants you to know about Saturday Night Live, I guess, and Google wants you to know where Herald Square is. But there's, when having a map, you can choose what kind of base map you want. For some folks this isn't important, but for others it's really important, say for legibility. If any of you have ever used Google Maps for biking directions, you might notice that if you turn on the biking layer, the base map changes. And that's so it can de-emphasize certain features that aren't so relevant to you on a bike, so that you can actually better see where the bike paths are. Anyhow, it's possible to design and make your own base maps. I don't have time to get into that, but there's also a wide variety of providers out there that have beautiful styled base maps that you're welcome to explore if you don't find yourself satisfied with the popular options. Sorry this isn't a little bigger, but when making marks on a map, you want to encode those points in a certain way, sometimes to express a certain idea. So on a previous map in this presentation, I showed a bunch of bubbles of different sizes. So size is one way that you can capture meaningful information to compare one place to another place. But you have other tools other than size to use. So you can have points of different shapes. You can have different hues, different values. There's a map online. I forget what it's called, but it's the one that shows the wind patterns across the country, and so that uses orientation to show which way the wind currents are going, and so forth. So when thinking about what you want to express in your map, some unique symbols might be useful for your cause. Projections are something that everyone who makes maps has to run into. I think, can I open this? So a projection is basically trying to make up for the fact that we're on a globe and we can't look at the globe from where we are, so we need to project it onto a flat surface, and there's various methods of doing that. Some types of projections suppose that you wrap a cylinder around the Earth and then kind of map the boundaries onto the cylinder. Some use a cone. Technical details aside, what it means is that you get very different sizes and shapes based on what kind of projection you use. This little tool just lets you overlay different projections onto each other to see just how different they can turn out. And there's some pretty wacky ones on here. But the point is that projections exist. And if you download a data set from somewhere else, you might have to deal with whatever projection they put their data in. So depending on what you're trying to do with that geographic information, and if you're trying to, say, merge it with a different data set or upload it to a certain base map, things might not align the way you expect, and you could blame projections. And there are some ways to resolve that, but all I wanted to say on that was that beware, it's a thing. It's less of a thing if you're making really local maps, right? So if you're zoomed in on this particular block in Cambridge, the projection you choose is not necessarily going to skew things all that much. But nonetheless, it could be an issue. Another thing I want to talk about is scales. So earlier I showed a choropleth map, and you can actually color a map in a variety of different ways given the same data. Not sure this table is the best example, but say you have a data set that kind of looks like on the top where maybe this left value, leftmost value is 0, and maybe this rightmost value is 100, and the vast majority of my values fall in between 0 and 20 or so, and after that they kind of get a little more sparse, and so on. Well, if you wanted to color these dots based on where they are in this data set, if you took, depending on how you divide up the data set, you can get very different images. So all this shows here is a few different types of scales that are conventionally used in geography. So quantile, I believe, is basically trying to divide the data set into 3 equal parts. So if I actually don't know how many dots are in here, but if there were 60 dots here, maybe, and there's 3 categories of color, each category would cover about 20 dots, right? So mapping that out onto these dots, we end up with one really long red bar and smaller other bars. How this would translate to a map is basically you might have a lot of your areas colored in a certain way, even though within that category there's a very wide spread of data. I'm not sure if I explained this perfectly well, but basically, depending on what scale you decide to work with, you can create a very different impression in a choropleth map. And that's something to be aware of both when you're making a map and also when you're looking at other people's maps, or looking at stuff such as election maps where you're convinced that this much of the country is doing a certain thing, but you don't know what scale they're using. So, something to be aware of. Related to that, I want to talk color scales. This screenshot is from a wonderful tool called Color Brewer, where you can go define your own color schemes and color ramps. So for some quantitative data, you might want a sequential color scale where the colors get either lighter or darker based on whether your metric's increasing or decreasing. These often would be a single hue, though you can kind of blend colors and get creative with it. A diverging color scheme would be similar, except you would have some sort of central neutral-ish value, or perhaps the average value that might be, in this example, is white. And then as you go more in one direction or the other direction, you get into darker, more saturated colors. So this wouldn't be appropriate, for example, for if you had something that you wanted to show from 0 to 100%. And then qualitative is just for when you don't have a quantity necessarily, but you have something else that you want to map. So maybe you're showing the most common language in a given polygon, and you have English and Spanish and German, and they're like one's not more than the other, they're just different categories. And I highly recommend, if you do anything with color scales, I highly recommend Color Brewer because it could also recommend colors that print well and colors that are colorblind safe, which is pretty important given that the whole point of putting color on maps is often to be able to distinguish certain areas. Another piece of terminology I'll throw at you is there are vector formats and raster formats of data. This will be a bit more relevant when we get into geographic information systems, but basically they could both represent geographic information, but they're encoded in different ways. So vector information will basically contain the coordinates that tell you like what shape a certain thing is. A raster is a bit more abstract, and I kind of think of it like you take the surface of the earth and you just make a painting over it. It's based on the values of each pixel or each square, like in a grid of a certain size. It's usually used for stuff like elevation data or ground cover. I'm not as familiar, I don't use a lot of raster stuff, and in most maps online that you'll see, there's not a lot of raster going on, but for stuff like satellite imagery, it's a must. Back to this thing. So most maps that I hear people want are kind of in the moderate complexity, moderate amounts of data sort of area where you might have a little bit of interaction and you might have to process your data a little bit first to actually be able to show what you need to show. So luckily there's lots of ways to start to tackle that. And I'm gonna go through a lot of different things, but we'll see where we end up. So earlier I briefly mentioned geographic information system. I don't know how many of you are familiar with GIS. It's very well used in certain areas of municipal government, urban planning, and it basically is a system where you can store geographic information, you can process that geographic information, you can run queries, you can slice and dice your shapes in any way you want. Going back to the vector versus raster format from earlier, you have different file formats that could be ingested into these systems. So shape files are your go-to. And shapefiles are something you might find a lot in the web portals that I mentioned earlier. So if you do encounter a shapefile, you can throw it into a geographic information system and play with it there. By that same token, geotiffs are a bit of the same thing, just for raster information. So working with this usually involves kind of bulky desktop software that isn't always fun to use, but if you or someone you know has a mastery of it, it can be really useful, letting you run really powerful queries, which is what this screenshot, if you can see it, shows. And you can answer questions such as, I don't know, like, show me all the counties in the US where the population density is more than 10 people per square mile. Right, that's a pretty complex ask, but if you have population and if you have the shapes, since it knows the shapes and it knows the projection, it can tell you what the area of the shape is, and you can perform that calculation in a few clicks and get that result and make a new map based off of it. So the possibilities are kind of endless with GIS, and like I said, not always fun to use, but very useful. And some libraries offer the system to play with. If you're part of a university, your university will probably have it. The most popular commercial product for GIS is ArcGIS by ESRI. You might hear people who have to work with it full-time grumbling about ESRI or ArcGIS, but it is the golden standard in the industry. Alternatively, QGIS is a great open source alternative, so it's free. You can download it. You can set it up, play with whatever files, save your maps, make custom maps, and so forth. So this won't publish a web application for you, but it being a GIS software, you can process a map and you can style it and you can print it to a PDF or whatever you need to do. Another term, geocoding. So if you don't have latitude and longitude for your places, what do? You can geocode them. And so geocoding is basically the process of turning what us humans think of as a place to what a computer thinks of as a place. So it's like I'm thinking of the Statue of Liberty, and I kind of know where that is, but I can't really put it on a map with just that. Geocoding will take that phrase, consult with a database, and kind of try to make its best guess as to like which place it actually is, and if it's in its database, then it'll find it. Statue of Liberty, oh, it's at 40 degrees latitude and negative 74 degrees longitude. There are some paid services that do this and some free services that handle this as well. It is something that I see a lot of people run into when trying to map a data set that they have that is not necessarily geocoded. And it's something that can be difficult based on how prepared your data is. So if you have addresses that have a lot of typos in it, for example, a geocoder might not be able to reconcile that and identify the places properly. So it can be a bit of a trial and error process, but but on the other hand, it's a very powerful tool because you could ultimately get coordinates for anywhere and be able to use that. And I just want to note that reverse geocoding is also a thing. It's the opposite. One thing I see, so this is a map of population change between 2017 and 2018, derived from census data. And census data is one of the more popular applications of that I see people make around here, just because census data tends to be freely available, and it tends to be pretty interesting and relatable to everyone and everywhere, whether it's demographics, economic data, income, race, ethnicity, what types of places people live in, and so forth. But geocoding would be pretty useful in any problem involving census data. If you're looking at something specific, like certain businesses or certain points, and you want to be able to identify what kind of neighborhood it's in, like if it's in a wealthy suburban neighborhood, or if it's in a up and coming rural place, you'd have to be able to geocode place. If you don't know where your information is, you need to geocode it and be able to match it with sources such as the census data, to be able to make these sort of comparisons and answer those certain sorts of questions. Okay, Geo JSON. I think this is the only code example I have in this presentation. Earlier I showed a tool called geojson.io, and basically this is one of its types of outputs. So what we're looking at right here, it's truncated because the numbers actually go on for a really long time, and I didn't want to fit that all in this screen. But what it will ultimately output is the state of Colorado, which I suppose is not the most exciting, given that it's a square or whatever. But GeoJSON is a type of format where, and there's a whole specification online of exactly how it works, but you basically define a feature. It has a field called geometry that describes the type of geometry you're looking at. So you can have a polygon, you can have a line, you could have a point. The coordinates are actual world coordinates, where the vertices and arcs are along that point, along the polygon in this case. TopoJSON is a very similar format, except it encodes the coordinates a bit differently, so that in order to be more succinct and give you a smaller file format. So for example, if you had a file representing the boundaries of every state in the US, there are a lot of overlapping boundaries, right? Colorado touches a bunch of other states, and so instead of drawing those boundaries over and over again for every state, TopoJSON has a way of kind of reconciling that in a way that still keeps the data useful. You can still define certain states, but it reduces the redundancy in how it draws the information. But anyway, this is getting a little into the weeds, but these are very common formats to find geographic information in online as well, particularly those that go into web applications. So these are something that you can directly feed into a piece of JavaScript code to output a map. Speaking of JavaScript code, I'm going to start closing out with just a list of different libraries that might be interesting. So if you want to do a web app, JavaScript is usually the relevant language that you'd want to look into. And some really popular mapping libraries for this are Leaflet, Mapbox, Carto, OpenLayers, Cesium. Deck.gl is something that Uber created that can that supposedly works for really like complex 3D, like it's high performance, D3. I don't have time to get into any of them now, but we could leave that for a future exercise. Python also has a lot of tools, so if anyone's a data scientist here, it's surprisingly easy to fit geospatial analysis into a data science-y sort of workflow. But anyhow, there's some libraries for that. I didn't list any for R, the statistical programming language, but there's a few libraries for R. There's a lot more for every language out there. I was going to have a slide on command line tools that could be used to translate between different formats, but and talk a little bit about databases, but instead I'm just going to post a link to a list called Awesome Geospatial, which lists probably hundreds of different tools and libraries organized by language. So if there's an area of programming that you're familiar with, you can just go there and find something hopefully useful. So, like I said earlier, I wanted to throw a lot of resources at you. I have a list at the end here of even more resources. Some of them skew more toward programming, and then some of them skew more toward design and cartography and colors, and some of them get more into the technical kind of, this is what you need to do with this file format, and others don't. So so I'm hopeful that there's something here for everybody. Like Danny said earlier, Maptime is a place where we talk about all this sort of stuff. So if you're interested, we're on Meetup.com, just like Code for Boston is. And I have not put this talk up yet, but when I do, it will be at maptimeboston.github.io/map-modalities. Yeah. So I know that was a lot, but thank you all for listening. Open to questions. Or I'll just throw the link at you and you can ask me questions later.
I think it's like if anyone is interested in any specific tool or GIS program and you want a tutorial, shoot us a message and maybe we can do it on Maptime.